Okay, so today, after a long weekend for the kids, we're going to take a day of just proving some more and reminding you what the common things are when you're proving. Here's one of those common things. Cosine squared plus sine squared equals 1. But you can't just look for that. Imagine you're in the middle of a proof and you see this. Can you see how that's related? It's that same thing except it's been solved. What's it been solved for? Cosine. So you could replace this with cosine squared. This one's a little bit of a mind bender. I sometimes see it backwards. If something's exactly backwards of how you want it to be, the reason I want it to be the other way is because if I just subtract sine squared from both sides, then, wait a minute, it's supposed to be 1 minus sine squared, and it says sine squared minus 1. If it's exactly backwards from what you wanted, then you can factor out a negative 1 and switch it around. Let me show you what I mean. If I had 2 plus 5, and that comes out to 7, then switching it around doesn't do a darn thing. But if I have 2 minus 5, and that comes out to 3, do you get that I can switch that around if I want, but it wouldn't be the same, would it? But if I factored out a negative 1, it would. Think about that for a second. 2 minus 5 is negative 3. 5 minus 2 is normal 3, so you'd have to do something to fix that? Factoring out a negative 1 switches things around. So do you get how, if I have this in a problem, it's backwards from how I want it? So how do I flip it around? Factor a negative 1. And if I factor out a negative 1, it switches. Now I can still replace this part with, what is 1 minus sine squared? Cosine squared. And now I have negative cosine squared. And that works much better in case I have a cosine on the bottom and I want to like cancel it or something. I can still do my canceling. There's just a negative in front. All right. Along those same lines, see if you and your partner can figure out what I would want this to be the other way around, but it's backwards. 1 minus secant squared is equal to something. Again, it's backwards from what I want it to be. So try to figure out how to manipulate this into this, except it's going to involve factoring out a negative. All right, these two rows slide next to each other. For today, we're going to have you move back 1 seat, and then we got those set up perfectly. You guys are going to make a group of 3 right here. These 2 rows slide next to each other. For today, can you, young lady, move up to the front? I don't want to see your name on the video. And then these 2 rows slide next to each other. And can you work as a group of 3 here? All right. So, again, I know normally this would give you the opposite of this. So figure out what I could replace it with. I'll pause for a second while you guys figure that out. If I subtract 1 from both sides, I would get secant squared minus 1. But wait, tangent is secant squared minus 1, but it's not 1 minus secant squared. So you can't just say, oh, this red thing is just tangent squared. But what is it? Negative tangent squared. Another way to say it is you can factor a negative 1 out of this, and it'll become this. It switches it around when you factor that negative 1 out. Okay, so final answer, this is tangent squared. And so you have negative 1 tangent squared, or negative tangent squared. All right, next one. Take a look at this one, the 2 of you, and would you please solve it for 1? 1 is equal to what? And then solve it for cotangent. It's already solved for cosecant, 1 plus cotangent. But what is cotangent? And what is just 1? Pause for a second as you solve for 1 and you solve for cotangent. Yes. Nice. Raise your hand if your group had that. And then, do you recognize that that can be factored? You didn't have to factor it, but do you get that it can be factored? Perfect square minus a perfect square. That's just the same as like x squared minus 4. It could be factored to x plus 2 and x minus 2. So would your group please factor this now? That's another thing you got to know how to do. You got to be able to factor out a -1 to do what I just showed you a second ago. You also have to recognize every time something will factor, I bet you're going to factor things at least twice on the test. Or if you don't notice that something can factor, you'll be stuck. Okay, FK, what did you get when you factored them? Do you have it factored? Okay, then you got to do it with me here. Cosecant and cosecant is what you get when you factor a cosecant squared. And then who remembers the rest of the kind of like the signs in there? Yes? Exactly, cosecant plus and cosecant minus. And then can you finish the deal now that you see the pattern developing? Okay, I really think you can. This last one is just cotangent squared, so... And cotangent. All right, so it was cosecant minus plus cotangent and cosecant minus cotangent. All right, that's factored. And then, did you solve it for... It was kind of the extra add-on was the factoring thing. So what was the other thing I was going to have you solve it for? Cotangent. If I get this alone, I just have to subtract 1 from both sides. And it's cosecant squared minus 1. Do you get that if it had been exactly backwards, and it would have been 1 minus cosecant, you could just flip it by factoring out a what? -1. Okay, good. All right. There is a list here of strategies that are very good strategies. These are not easy questions, so you got to have tools. You got to have like ways, like here's what I could try. Again, on this page, on the top one, it says try working on the more complicated side of the identity. I think we've been doing that pretty consistently. Most kids get that. No big deal. Next, they're saying that these are used a lot, reciprocal and quotient. So let's just make sure you got your reciprocals down. Sine could be replaced with 1 over, not cosine, cosecant. The flippin' sisters. Okay. Sine is 1 over cosecant. And if I pick a random one, you should be able to tell me what the sister is. So what's secant's sister? Cosine. So the secant is equal to 1 over cosine. And then what if I pick cotangent? Same as 1 over tangent. All right. And then the last thing is the quotient identities, and there's only 2 of them. Tangent is what over what? Well, it's y over x, so tangent is sine over cosine. And what about cotangent? All right, so flip it around. All right, and then common denominators. Oh my gosh, that is such a big deal. On last night's homework, if you didn't understand common denominators, you probably couldn't do it. All right, and I want to just give you a second to process something like this. Would you guys please change this into the quotient? You should know what I just read it a second ago. Tangent, it's on the sheet. If nothing else, if you want to pull up the sheet, I've got it on the wall here, which I get is incredibly small. I'll scroll it down so you can see the top part at least. But you need to find the identity sheet that I posted for you on Schoology. and you should be able to find where tangent is. Then I'd like you to get a common denominator for that. Like, what do you mean denominator? It doesn't even have a denominator. Well, once you replace tangent with a fraction that it is, then 1 plus that can't be added together until you get a common denominator. All right? In case that was still too vague, EL. Can you tell me what tangent gets replaced with?
1 over.
Not the one we were looking for. That's a reciprocal. I was looking for a quotient. That's one of these two guys. All right. Now, find a common denominator and add them together. Pause for a second while you try that. Now, a lot of kids started with 1 over 1, which is great, but then how do you get this next little step? Talk to your partner. Hopefully one of the two of you can figure out how to make this all work. Get the final answer added together so it's one single thing, not two separate things. One big fraction. So I was asked a good question, like how far do you simplify it anyway? Well, I should probably make this into a proof, and I'm going to finish this. Let's say we wanted to figure out that 1 plus tangent would be equal to secant squared. Is that what it actually equaled? Was it? Is that what you got? Just plain secant? Did anybody get secant squared, or did anybody get plain secant? Okay, I better not try to do that then. I thought there was a nice simple, it equaled something. All right, let's just follow through the little steps here. So this would be cosine over cosine. Just trying to judge how far people got. How many people got that far? You need to multiply by that. Okay, good. That's the first step. Then they have a common denominator, and then you have to add the tops. Cosine theta plus sine theta all over cosine theta. Then, common mistake, people think I can cancel these. Why can't I cancel those? It's part of an add problem. Can't do that. All right. Next, could I do more? What else could I do? Like this? Can't do that. Because this is part of an add problem. So I can't do that. If I could, that'd be awesome. And the answer would be sine, but it is not true. Can't do that. Thank you for trying. Can you think of something else? Yes? If they were squared, it would equal 1. But they're not squared. Good question. You can square most of these things, like squared, 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 all over the board here. You can square almost everything. But you can't take sine plus cosine and just square it so that it can equal 1. You know what I mean? Like, this is different than that. If it was squared, then I could do it. And you're right, I did say that most of the things on the sheet you could just square. But see, that one's already squared on the sheet. You know what I mean? So if you want to take things that are not squared that are on the sheet, like for instance, cosine x is equal to 1 over secant. Sure, go ahead and square things. But you can't take something that's not on the sheet and then square it and then say, oh, now it's one of the ones on my sheet. No, can't just square that. Now, if I wanted to multiply by cosine plus cosine, then I could get it to be squared. And it's called its conjugate. That's the next concept. First of all, we do not have to do this. If you got this far, you were good. Raise your hand if you got that far. Okay, good. Then you were good. That's okay. You don't have to go any further. But what if I multiplied by cosine theta minus sine theta? If I did that, I'd have to do it to the bottom. And that is called its conjugate. Why? Because now that and that are kind of like opposites of each other. They're called conjugates. And that, when multiplied out, makes cosine squared minus sine squared. That whole thing across the top would become cosine squared minus sine squared. Is that on the sheet? No, but it's going to be useful in a second. Now, that concept of multiplying by something like this, that concept of a conjugate, that's going to be used on the test. You got to know, whenever you see something like 1 plus sine, and it's not squared, the way to get it to be a squared is to use its conjugate, which would be 1 minus sine. Right, so that concept's important. Now, step back from that for just a second. And I think I'm going to stop on this one. I've gone far enough on this one. I've showed you how you could use a conjugate. Now, it didn't really get me anything. On the bottom, I'd have cosine squared minus sine cosine. But that's what conjugates are. And now I'm going to go back to my list of big helpful things, because I've already talked about common denominators. Yay. Next, the Pythagorean theorem identities. We already talked about that. Let me give you an example of one. 1 minus cosine squared. You got to be able to just right away, not have to like look for a long time, find it on your sheet. It's something on the sheet except rearranged. What is it? One minus cosine squared. What is it? That's sine squared. All right. Why? Because it was sine squared plus cosine squared is equal to 1. And if I subtract cosine from both sides, I'm forgetting the thetas. Sine squared is 1 minus cosine squared. Okay. So, what is cotangent? What is squared? Sorry. What is cotangent squared? In the context of these Pythagorean identities, hint, it's 1 minus something or 1 plus something. Look on the list. Talk to your partner. Figure out what you guys think cotangent squared is. Not the 1 over. It'd be 1 over secant squared, but that's not what I'm looking for. I'm looking for a 1 minus something. Here's the saying. The 1 with the coat is, do you remember? Cozy. And if I wanted cotangent alone, I'd subtract 1. Did you get cosecant minus 1? Raise your hand if you had that one right. Awesome. Did you also recognize right away that that can be factored? Because there's 2 perfect squares that are being subtracted. Cosecant squared minus 1 could factor into CSC plus 1 and CSC minus 1. You don't have to put that, but that's something you could take out cotangent and put in that, which can be factored to that. All right, so trying to give you all these little tools that we've taught you so far. Now you're going to use various tools like this to, in conjugates, which we just talked about. If I had 1 over sine minus 1, what's your gut say to multiply by right away? Sine plus 1. Very good. The only other option would be replace sine with its sister, 1 over cosecant. And then you'd have to get common denominators. So there's 2 ways to handle that original question of 1 over sine minus 1. Since it's not squared, you got to right away think, well, the only way I can get it to be squared is multiply by its conjugate. Which, by the way, would be what? Sine plus 1. Okay. So we talked about conjugate. We've talked about common denominators. We've talked about how if something's the opposite of what you wanted, then you put in a negative. Like factor out a negative. We have talked about how These come up a lot, reciprocals and quotient. Remember the quotient is sine over cosine? And that was, what is sine over cosine again? Tangent. And you can always flip that one and do cotangent, which would flip these two, and it'd be cosine over sine. All right, all of those are really, really powerful strategies. And then this last one is a nice little hint. If you find yourself working with one side of the identity, try starting with the other side of the identity and see if you can find a way to bridge the two parts of your work. What they mean is, go to, everybody, this page. Let's say you're stuck on this problem and you've done some stuff and it doesn't seem to be working. And just for a minute, it's not cheating to go over here and say, what could I replace cotangent with? 1 over tangent. And that alone might be enough for you to say, oh, so I really want this thing to be a tangent. I see what to do now. And then you still have to back this back off like you never touched it. Because remember, you can only touch one of the two sides. But do you get, by just going a little, like kind of like a little ways with it, you might figure out, this one's supposed to equal cosecant. But that really means that it has to equal 1 over sine. And maybe that's a good hint when I'm in here that, oh, getting sine in there is a good thing. If I'm getting it to sine, I just have to flip it over. So anyway, you can look at the other side and break it down a little bit, and that sometimes helps. All right, enough talking about all the tools that you have. I've already said this equals something today. I already suggested that if you can factor it, you should. I have suggested that you replace tangent with its, what 1 over cotangent sometimes, but more often, what's tangent get replaced with? Cotangent is what again? Sine over cosine. Okay, good. There's my hints for these. Try proving these 3 with your partner. This is a lot like what the test is going to be like. These are not super easy. There's 2 medium. Actually, there's 2 that are kind of easy and 1 medium. Start with the 2 on the left. Numbers 1 and 2 are kind of easy. This is not the conjugate thing because it's already squared. Don't need the conjugate for that one. All right, I'm going to pause for a second. Let me try to prove both of these. The rules of proof, only touch one side. Make sure you're only doing things that are directly on the sheet. Pull off one identity and put in another. And you can do basic math, like factoring things out, like multiplying things out. Like some people fear that you can't do this. No, you can do that. That's basic math. That's called distributing. Now, you may not want to distribute yet on this third one. All right. Enough hints. I'm going to be quiet for a bit while you guys try these. Okay, let's see if you got this. Did you figure out that the one with the sec and what's that saying again? The one with the tan is what you seek. It shouldn't be because they're probably going to get skin cancer. But anyways, so what's the actual thing? Secant minus 1 because they subtracted 1 from it. See how it's really tangent squared? I can put that there. You don't have to show all of that work. It's a fact we had on the sheet that we just, you can take the fact and rearrange it. So it's tangent squared. How many of your groups were smart enough to note that the bottom should be changed into tangent squared? Raise your hand if you did. Awesome. Then why is that good? Because you got tangent over tangent squared. And then you can separate it. Can you just go like cancel the tangents? No, there's no such thing as that. There is this though. Tangent over tangent, tangent. And then 1 can cancel, and 1's left on top. And then it's 1 over tangent, and then you have to go the last step. Of course, you can't say just that equals cotangent. You have to go one more step and say cotangent equals cotangent. How many are able to prove the easy one? Okay, good. Then for the next one, let's pull out the dice of destiny to see who's going to tell me what to do on number 2. It's really not that hard. Row 5, person 1. It's you. I'm going to give you a hint then. Factor out a 4. Do you get it as a 4 in both of them? After the 4 comes out, tell me what you have. Equals 4. And then, do you see it? I bet you do. Maybe you don't. There's something there that just screams out, simplify me. Nope, it already is factored. Because there's a plus in here, you don't want to try to factor it again, because it's got a plus, not a minus. Yes, sir. Good question. I'm glad you brought it up. I hear you that it seems like we should divide by 4, but you can't. In proofs, you can't do stuff to both sides. You can only do stuff to one side or the other. Yes? That equals 1. It's right on the sheet. Cosine squared plus sine squared is 1. So then I just replace for 4. 1 equals 4, and then 4 equals 4. See how easy that one was? Why? Because I knew what that was off the sheet. If you don't have a good grasp of what's on that sheet, then you can't know to look for that. Okay, next. On problem 3. I know you might not be done, but I just want to know the first step. Row 3, person 3. That's you, EL. What did you try on number 3? Okay, what did you try? You replaced that with 1 over tangent. I agree, probably not the way you wanted to go. And we could do it and show that it, all the work, but nope, it's probably not going to work out. Thanks for trying. Do you get there's a million things that you can try? Yeah, so that didn't do it. Remember, yes, go ahead. 12-minute warning. Where? Yes, you take out the tangent, and everybody try replacing the tangent with sine over cosine. Didn't I give you the hint that that was going to come up a lot? I believe I said that during this hour, right? All right. So try this. And take it from there, and hint, don't forget that you can multiply things out. You might want to do one more replacement and then multiply it out, or you can just multiply it out. I'm going to pause while you give this a try. Talk to your partner about it. See what's working, what's not working. I'm going to give one more hint. After I multiply this times this, the cosine drops and I have just sine. Plus, when I do this times this, I have cosine, cotangent. The key is, can you get cosine and cotangent to simplify down a bit? Cosine times cotangent. Maybe you want to get a common denominator then. Common denominators, I said that would be used. This is your chance. I'm giving you the first step. See if you can take it from there. In case you can't read this, it's cosine plus cotangent. Pausing for a second. Okay, let's see if you pulled it off. Just a second here, I'm going to... Uh-oh, undo. Question? Okay. So I'm just deleting this so that I can remove this and show you the steps. Oh no, it erased them. Okay, pausing. Okay, I agree. But take a look at this. You get how this gets multiplied out, and when the cosine times is by this, the cosines cancel and you get just sine. And then we replace cotangent with cosine over sine. That's the backwards from tangent. Then when the cosine gets times here, it becomes cosine squared over sine, which doesn't look very nice. Then you realize with this green here that you can get a common denominator of sine. And why is that good? Because look what the top's going to be. Sine squared plus cosine squared. And on the bottom you have sine squared, or sine, regular sine. So the top becomes sine squared plus cosine squared, which equals 1. And it's 1 over sine, and that's cosecant. All right. That was a normal difficulty problem. Which part don't you get, the sine over sine? They just multiplied that so that they get a common denominator. Do you not understand why the green thing is in there? Okay, you can multiply by sine over sine. Why would you do that? So that you'd have the common denominator of sine then at the end.
Isn't sine over 1 sine over sine?
Sine over 1 is not sine over sine. Sine over sine is equal to 1. That's true. Okay, so they multiplied that green stuff to get it to have a common denominator. And then it did. It had a common denominator. So then you could add them together, and the denominators are just sine from there on out until it gets to the end. And then 1 over that is cosecant, and cosecant is cosecant. All right. Now, your homework for tonight is to do, these two are pretty tough, and the answers are not there. So it's something, if you want to try it, you can. They are true statements. Okay, and just so you can, if you want to, follow along at home, I'm going to show you what the answers are. Just give me a second here. So if you want more practice of these, here's that one. And then, please stay quiet and listen. I'm showing you the answers for the second one in case you want to see how nasty that one is. Now, the two that I'm assigning, though, are these two. 91 and 93. The answers are there for these two. So try them, check them, and that's, you only have those two problems for tonight. If you decide not to practice, don't expect to do better on your test. It will be impossible if you don't practice. That's all I got for you for today.